Hydraulic-Set Retrievable Packer. Full System Overview. A hydraulic-set retrievable packer is a downhole isolation tool used to seal the annulus between tubing and casing. Unlike mechanical set packers, this type does not rely on pipe movement. It is set entirely by applying surface pressure to the tubing. The illustration shows all major packer components. 1. Hydraulic setting chamber. This is where tubing pressure is applied and converted into mechanical motion. A sealed chamber allows pressure buildup behind the piston. 2. Setting piston. When surface pressure is applied, the piston moves downward, initiating the setting sequence. The movement transfers energy to the slips and sealing elements. 3. Slips and slip cones. Slips are serrated metal wedges that bite into the casing wall. The piston forces the slip cones under the slips, pushing them outward and anchoring the packer. 4. Sealing element stack. This rubber/elastomer element expands radially when compressed between metal retainers. The expansion provides pressure containment and isolates the annulus. 5. Lock ring mechanism. Once set, the lock ring holds the packer in position even if pressure is removed. 6. Equalization ports. Used during unsetting to equalize pressure across the tool, ensuring safe retrieval. This illustration represents the full mechanical architecture of the packer, showing how hydraulic energy translates into mechanical anchoring and sealing. Hydraulic setting mechanism. Pressure-activated setting sequence. This illustration shows the step-by-step mechanism by which the packer is hydraulically set. Step 1. Applying tubing pressure. Surface pumps increase tubing pressure, which flows into the hydraulic chamber. Step 2. Pressurized chamber activation. Pressure builds inside the chamber and drives the setting piston downward. Step 3. Slips move outward. The downward piston motion pushes slip cones under the slips, forcing them outward and anchoring the packer firmly into the casing. Step 4. Sealing element compression. Continued piston movement compresses the rubber element stack. This radial expansion creates a pressure-tight seal between tubing and casing. Step 5. Lock ring engagement. A ratcheting lock ring engages automatically to hold the packer in the set position even after pressure is removed. This illustration clearly demonstrates how hydraulic energy is used to convert pressure into mechanical anchoring. Establish a primary pressure barrier. Lock the packer securely in place. Because no pipe movement is required, this system is ideal for HPHT, deviated, or horizontal well operations. Where hydraulic packers excel, advantages and applications. This illustration explains why hydraulic set packers outperform mechanical set packers in many conditions. 1. Deviated wells. In high deviation, tubing drag prevents reliable weight transfer. Since hydraulic set packers do not rely on compression, tension, or rotation, they can be set safely without pipe movement. 2. Horizontal wells. In horizontal sections, transferring slack-off weight is almost impossible. Hydraulic set packers maintain excellent reliability because setting depends solely on pressure. 3. Live well operations. When the well is under pressure or flowing, hydraulic setting avoids pipe movement under load, reduces risk of packer misset, allows safer operations. 4. Deep wells with friction/drag. Hydraulic set packers can be set regardless of frictional losses or differential sticking risks. This illustration reinforces that hydraulic set retrievable packers are the preferred choice whenever mechanical set tools cannot be reliably activated. Hydraulic packer failure modes. What goes wrong? This illustration focuses on the common failure modes associated with hydraulic set retrievable packers. 1. Setting piston plugged with scale. Scale, sand, and cement fines can clog the hydraulic port, leading to incomplete piston stroke, slips not fully engaging, elements not sealing properly. 2. Hydraulic chamber leakage. If O-rings or seals are damaged, pressure cannot build up. This results in a soft set or complete failure to set. 3. Blocked release ports. Debris blocking equalization ports prevents pressure balancing during retrieval. This creates a stuck packer scenario because the differential pressure keeps the slips engaged. 4. Partial element expansion. Low pressure or obstruction in the setting mechanism prevents full compression of the sealing element. This leads to annular communication and potential barrier failure. 5. Slip damage/poor bite. Slips may ride on casing scale or corrosion and fail to bite. This creates a major safety risk because the packer can move under differential pressure. This illustration teaches technicians and engineers how to recognize early warning signs and understand why packers may fail during high-risk workover operations. Retrieval sequence. Unsetting a hydraulic-set retrievable packer. This illustration demonstrates the detailed unsetting and retrieval process. Step 1. Apply upward pull. A controlled pull is applied through the tubing string to activate the packer's mechanical release mechanism. Step 2. J-slot or release mandrel engages. The packer's release mechanism disengages the lock ring and allows the packer to unset. Step 3. Equalization ports open. Before the slips retract, pressure across the packer must be balanced. Equalization ports open automatically, removing any trapped differential pressure. Step 4. Slips retract. The slip cone moves upward, allowing the slips to retract inward and disengage from the casing. Step 5. Sealing elements relax. The elastomeric elements decompress and return to their original shape. Step 6. Packer pulled out of hole. With slips and seals disengaged, the packer is safely retrieved through the casing. This illustration is critical for training because improper retrieval is a common cause of stuck packers, tubing damage, fishing operations, NPT during workovers,